Hello, boys and girls. Welcome to Mrs. Bandu's Math Movies. This is Lesson 6-5, solving inequalities by adding or subtracting, and it's for my Course 3 class. Okay, so that is our objective today, to write and solve inequalities using addition and subtraction. Okay, so basically we have these two properties, the addition and subtraction properties of inequality. Basically, it tells us that if you add or subtract the same number on each side of an inequality, the relationship between the two sides does not change. Let me make that a little bit larger so it's maybe easier to see for you. And focus. All right, so arithmetically we could say 8 is less than 12. So if I say 8 plus 3, I can still say that 8 plus 3 is less than 12 plus 3. So I've added the same amount to each side, and I have not changed the truth of the inequality. Similarly, I could subtract 4 from each side, and 8 minus 4 is going to be less than 12 minus 4, because 4 is less than 8. Okay. Also, 10 is greater than 7, so 10 plus 5 is greater than 7 plus 5. I've added 5 to each side of that inequality. And 10 minus 2 is greater than 7 minus 2, because we started out with 10 is greater than 7. Okay? Algebraically speaking, with variables, if A is less than B, then A plus C is less than B plus C, and A minus C is going to be less than B minus C. If A is greater than B, then A plus C is going to be greater than B plus C. And A minus C is going to be greater than B minus C. Okay? Now these are true as well, similarly for greater than or equal to, less than or equal to as well. So they apply just like that. The definition of an inequality is a mathematical sentence that contains greater than, less than, greater than or equal to, less than or equal to, or not equal to, with a slash between the equal sign. Okay? Through the equal sign, excuse me. Okay, so the first four are the ones that we're going to focus on. This is just saying that two things are not equivalent. Doesn't tell us a whole lot about other than that. Okay, so let's look at number 1. Solving inequalities by adding. After the hairdresser cut 3 inches from Rapunzel's hair, her hair was at least 15 inches long. How long was her hair before she had it cut? Okay, so basically the length before it was cut minus what was cut off is at least 15 inches. So at least is a greater than or equal to statement. In other words, it could be that amount, but that's the smallest it could be. It could have been longer as well in this case. So let's say that L is the length before the cut. So L, the length before the cut, minus 3, how much was cut off, is greater than or equal to 15. Okay, so let's get started here. We have our inequality statement is L minus 3 is greater than or equal to 15. Again, my goal is to isolate the variable, and I'll do that by using the addition property of equality, and I'm abbreviating. So I'm going to add 3 to each side of the inequality. So if I subtract 3 and add 3, those zero out, so L has been isolated. Greater than or equal to 15 plus 3 is 18. So Rapunzel's hair was at least 18 inches long before she had it cut. Okay. I'm going to move on to the next one. And the next one is actually going to ask us to graph as well. So I'll have to point out a couple of things about graphing as we go. But first of all, let's go ahead and solve. We have p plus 3 is less than negative 5. So we're going to isolate the variable by using the subtraction property of equality. And again, I'm abbreviating. So instead of adding 3 or to undo the addition of 3, I will subtract 3 so that I can isolate my variable. So I get then p is less than negative 5 minus 3, which is negative 8. Okay, so it wants me to graph as well. Now, just a couple of side notes about graphing. First of all, if we have a less than or a greater than symbol, you will use what I call an open dot. Okay, so this is for greater than, or if you have just less than. If you have greater than or equal to or less than or equal to, you're going to use the solid dot because the number that you find is actually part of the solution. Whereas, if it's just greater than or just less than, those numbers are not actually part of the solution. Okay, we will talk in a little more detail about that in class as needed as well. So, but this basically tells me all numbers less than negative 8 make this true. So, I'm going to put an open dot at negative 8, and then I'm going to shade my number line to the left to include all the numbers that are less than negative 8. And shade in your arrow as well because you want to show that that continues on. Again, if you needed to check one of these, I would pick any number in the shaded area, substitute it into the original inequality, and see if it's true. So let's take negative 12. Negative 12 plus 3, and let me jot that, negative 12 plus 3 should be less than negative 5. Well, that gives me negative 9 is less than negative 5, so it checks. There is a little more complicated check that we can talk about as well, but that's one way to check. Okay, so that was kind of short and sweet. There are a couple of inequalities here for you to solve. One says solve and graph. Here in number 2, you write your own and solve. Bring these into class for the next time we meet, and I look forward to seeing you then. Bye now.